All right, so I don't expect today's lecture to take too long. So there might be a little bit of time for me to talk a little about the calendar problem, for instance, for the PA6, which I think on GitHub Classroom, I think it was called PA7. I think there's just various reasons for that. So if it looks like it says PA7, but as long as it's a calendar problem, then it's fine. I specifically today just want to talk briefly about this concept of a design pattern. And we're going to talk about a very simple one. But what I want you to get out of the lecture today is not necessarily to remember what this Singleton design pattern thing is, but just to know that these are things that exist, that design patterns are out there to help you when it comes to programming. There's not a specific class that sort of talks about a bunch of design patterns. In my game dev class, I talk about several that are useful for game development. There are some that you just sort of learn naturally that are sort of part of object-oriented programming, and I'll talk about a couple of those now, some that we've sort of already been using, but we just haven't called them design patterns. But sort of throughout your sort of programming sort of career, or even if you're only taking CS1 and CS2 for another major, there are common issues that come up when you're programming, common types of problems that you have to solve. And because they're so common, people have come up with very good solutions to those types of problems. You might have to modify a little bit to fit with your exact software you're writing, but these solutions are sort of time tested. There's sort of expert programmers who've been doing this stuff, since sort of OOP sort of came around, more or less sort of 80s-ish, and people write books about them and show these types of solutions to solve particular problems in programming. So that's sort of what a design pattern is meant to do. So it's basically a problem solution pair. You have an issue. This solution is going to be a technique that solves that problem, and the terminology and sort of this idea is more or less borrowed from like engineering type discipline. Just think of it more like a structured approach. If I know I'm going to have a specific potential issue or something specific when I'm doing my programming that I might need to do, then this is just an approach to do it. And it sort of sits midway between the features of a language and an actual concrete implementation, actual concrete code itself. It's a way to program your code that you might need to modify depending on your specific situation, but it'll sort of give you things like flexibility, which is always useful when you're programming. So we've been using patterns like this. Some of them are built into object-oriented programming. Some of them are something sort of extra that is sort of out there that we've already seen. So for example, encapsulation. That's encapsulation and abstraction to sort of the same degree. It's this idea of packing all of your data into a class and then making your data fields private. That's a design pattern. And I'm going to talk a little bit more about this sort of encapsulation / abstraction in just a moment. I have another slide with it. But that is a design pattern. That's something that we have been doing. We've been making all of our data private. Exceptions are a design pattern. We've dealt with exceptions. We used exceptions for doing stuff with reading from a file, writing to a file, dealing with user input. They type in a letter when it's supposed to be a number. We can catch an exception. That's a design pattern as well. You have something that's going to crash the program, a runtime error. You want to provide feedback or correction to the user. So you have your problem and your solutions sort of pair, or your implementation pair that deals with that problem. That's an exception. In CS2, subclassing, or sort of the sort of more OOP name for it, inheritance, that is a design pattern. It's one that's used a lot, but it is still just a design pattern. Things like iterators, which we talk about later in a semester in CS2, those are design patterns as well. So these design patterns are everywhere. Some of them are very common that you use all the time, so this sort of encapsulation and abstraction. Some, not so much. Some you might use in very specific circumstances. But they're all these patterns that help you write better code, more efficient code, more flexible code, that sort of thing. That's what they're for. So for this sort of encapsulation pattern, the problem that you would sort of be solving with this is that fields are directly manipulated from outside. So you write a class, and you can change the data variable. You can change the data variables without having to go through a method. We haven't written a program that's sort of big enough to make this be a problem. But as you write more complicated software, as you write more complicated or more larger software, this can lead to things called dependencies that make it hard to change your code. You get all of these little tendrils of accessing data directly from classes all over your code. And all of a sudden, if you want to add, you're coding a game or something, you want to add a new feature. All of a sudden, you have to change a whole bunch of code in a whole bunch of classes in order to add in a new feature. The more code you change, the more chance you're going to break something. And the more chance it's going to be way more complicated to add even more things in the future. So this pattern makes you hide those components. You hide the data variables. You just make them private. And then you permit access only through methods. So that's what the getters and setters are. When I make when we had our rectangles and circles back in the OOP series of lectures, we would have like get radius or get height, get length, or set radius. We'd have those types of methods. Those are the methods. That's this pattern. We make those variables, we make the radius private, we write a get and set method. So you can still access the variable, but it must be done through controlled access via methods. So we've already dealt with this pattern. I just didn't call it a pattern. And this is the standard thing that you do when you're writing classes, is this type of pattern. You just don't normally think of it like a separate pattern. This is more of a standard OOP thing rather than a separate design pattern. But technically, it is a pattern. So there's a few categories that these sort of patterns, these types of patterns, fall into. The one that we're specifically going to talk about and code up a little bit today is called is a creational pattern. So it deals with creating objects. So when we say, let's see, we did our critter thing last time. When we say critter C equals new critter, if we applied some sort of pattern to that creation, then that would be a creational pattern, the pattern that we use, because that's the process of creating our critter. There's structural patterns. So the integration and composition of classes and objects. If you've used a lot of game engines use a very specific structural pattern. Since I teach the game dev class here, we use Unity, and Unity is its basis of how you're supposed to use the classes and objects is based on a structural pattern called it's the component pattern. So it's totally based on the component pattern, which is a structural pattern. It's how you sort of organize your classes and your objects. And then there's things like behavioral patterns. So how do you communicate between objects? There are patterns that deal with that as well. Something in like C# that I do show a behavioral pattern in the Unity class. So C# has delegates and events, and using delegates and events together is a behavioral pattern that allows you to communicate easily between objects. So there's lots of patterns out there. Like I said, there are books on different patterns for different fields as well. I have books on scientific programming that has a bunch of scientific patterns. Like if you're doing physics or chemistry or something on the computer, there are various patterns that are useful for that. I have game programming pattern books that talk about a bunch of stuff that's relevant for games. And of course, there's some overlap, but there's also a lot of difference as well. So whatever field you end up going into, if you're doing a lot of programming, there is likely books or stuff online or videos or whatever that talk about patterns that are useful for that particular field. And it's a great feeling when you're having a problem with a specific piece of code and you find a pattern that you're like, wait a second, this would make this so easy if I rewrote the code this way to use this pattern. So that's something that you'll probably come across. Potentially some professors will mention it, but there's no specific class just about a bunch of patterns. So usually it's in the context of other classes. So for the game dev class, we do talk about like 4 or 5 patterns that are actually useful for game dev. So the one I want to talk about, and then this is basically the end of the slides here. So the one that I want to talk about is known as the Singleton. I want to sort of preface this with a warning. If you go look up the singleton online, whether it's videos or in books or whatever, someone describing it, there's usually some really big caveats with it. It's not a great pattern that everybody uses. I talk about this in CS2 as well, and you sort of potentially start to understand a little bit more about it in CS2 and sort of why it might be bad. But it is not something that you should use everywhere. You can use it everywhere, but there are certain questions that you're going to want to ask before you use it. I limit the singleton's use to certain types of classes, so that's something that I'll talk about, and I do use the singleton in my game dev class. The problem that you'd be trying to solve here is sort of twofold. A class that only needs to be instantiated one time. So you only have one object of that class, and that's all you ever need for the lifetime of your program. That's the first part. And I just want to mention a couple cases where this might be useful. So we created our critter. We did this critter code last time. And if we were writing the sort of Tamagotchi type program, you're never going to have more than one critter. So a singleton might be appropriate. If you had, let's say we had we were using graphics and sound and stuff. We had all kinds of GUI or something with this. If you had some sort of sound class, a class that handled all of the sound in your program, you probably could make that a singleton too. Because you only ever need one. You don't need multiple classes handling sound. You might just have one class that handles everything, and then that's it. So there are places where having one object of a particular class is useful. Again, a critter, we only have one, and that's where our sort of game, that's all it needs. That's what needs to be part of this game, just one of them. I'm never gonna do this twice. So the singleton could be useful in that situation. But there's another piece to this. Should be available globally. That's the part that people have a problem with. This right here. The other part, one instantiated object, it's something that you might need in a lot of cases. But this is sort of two parts to this. Should be available globally. What that means is that anybody can access it. Anybody. Any class in your entire program can access a singleton. I'm going to show you how to do this in Java. I'm going to show you how you can set this up. But this is what a lot of people have a problem with, because this creates dependencies. The thing that I mentioned earlier, where a class or a lot of classes might rely on the singleton doing very specific things. But what if you go change the singleton? What if you realize, I need to change it and do this? You might break half your code, because half your code might be accessing that singleton because it can be accessible globally. So that globally thing can cause problems, and that's why people have a problem with singleton. If you don't sort of fully understand the sort of globally thing or that, it's not too big a deal right now. But I will talk a bit more about it in CS2, for example, after you get a bit more experience with object-oriented programming and playing around with OOP and some of the projects that I have folks do. If you're signed up for one of my sections next semester, this is something we will talk about again. Classes that you might not want to have be a singleton are basically anything else that needs to have more than one object. So if I was making a game and it was a card game, I'm probably going to want the cards to not be singletons, because I'm going to have 52 of them, 52 card objects. And if I'm creating like blackjack or something, even the deck itself, the deck of cards, that probably shouldn't be a singleton either, because most places, if you were sort of trying to simulate more sort of casino style, have lots of decks when you play blackjack all mixed together. So if you're thinking about using a singleton, you've got to think carefully about what needs only one object, and should it be available globally. And if the answer to either one of those is, or one or more of them are no, then you do not want to make it a singleton. So the solution to this, you can apply this to many different languages. Java has specific types of implementations. C# is going to be a little bit different. C++ will be a little bit different. You allow only one instantiation of this object through a private constructor. So when we go into some code, that's what we're going to look at. We're going to look at, what does a private constructor mean? And then you allow a single access point to reference the single index. So we're going to use some static stuff to do this. So this isn't very descriptive. The solution here isn't very descriptive. It's meant to be more vague because you should be able to apply this to whatever language you're using. So this doesn't specifically say use a static function and a static variable. It doesn't specifically say that because not all languages have that sort of thing. So let's go in and take a look at what this means for a specific class. So I'm not going to modify our critter one at all, but I did want to sort of have it up so you can sort of see that, yeah, we create one object and that's it. And our game, I'm using quotes here, our game only needs one to function the way we want it to function. All right, so I have a main class. So this is where we're going to create our object. So when we write our singleton, or thing that we intend to be a singleton, we'll say, whatever the name is, and we'll say, we'll have a new, I'll probably call it my singleton. We'll have something like this to create the singleton. So this will be the instantiation. But there's going to be some weird stuff that happens. So I have this base class. I'm going to make a new class. This one's not going to contain main, the one that I'm going to make, because it's just going to be our singleton class. So make a new class. I'm not going to do a check mark on the public static void main. I'm just going to name it. Let's name it my singleton. Say finish, and here it is. So it's the same stuff here. It's just public class, my singleton. There's a few things that we're going to add, and I want to create the constructor first. So remember, all of our classes need a constructor. So let's make a quick one. Typically, we make our constructors public. We're going to change that to private in a moment. I would say my singleton, and we can have it empty or whatever. Maybe I'll throw a print in here, just an printf, where I say created my singleton. So that's it, just a constructor. And I go back to my class that contains main, and all I'm going to do is this. I'm going to say my singleton, and we're going to just call this ms for my singleton equals new my singleton. I'll go back to the class here in a second, but I want to show you what this will print out. So I'm calling the constructor. So I get created my singleton. So that's all I'm doing in main. And again, my singleton just has a constructor with print. Because the constructor is public in sort of the current setup here, it can be accessed anywhere. Anybody can create a my singleton object, and that's what the ms here is. Ms is a my singleton object. This object doesn't do anything. It's not like a critter. It doesn't have a bunch of data and a bunch of methods or stuff with it, but it's the same type of thing. It's an object of my singleton type. If I change this to private, so I take the constructor, I change it to private. There's no error here. There's no reason why you couldn't give a private visibility to a constructor just in a class, but I have an error back in main. And if I hover over where it says new my singleton, if I hover over that, it says the constructor my singleton is not visible. So I actually cannot do this. in any other class. I cannot create this object. I can never call this function from outside. I can call this function from inside the class, but I can't call it from outside the class. And so at first glance, you might think, then how is this supposed to work? Only allow one instantiation via a private constructor. We just created a private structure and it allows no instantiation. We can never create it. So that's where a couple extra pieces come in to make this pattern actually work. So I'm going to create a piece of data. And this is going to look a little bit weird, but the data, we're going to follow the encapsulation and abstraction principle. So the piece of data is going to be private. And instead of being, an int or a double or something like that, it's going to be a my singleton. It's going to be of type my singleton. It's going to be a my singleton object, and I'm going to call it instance. The name, for instance, will hopefully become sort of more clear in the near future, but you can name it in principle whatever you want. The other change we need to make to this is currently an instance variable. It belongs to a particular instantiation of my singleton. It belongs to a particular object. So instead, I'm going to make this static. So remember what static does. Let's say I create a bunch of objects. Doesn't matter what of. Maybe they're all cards or something. We talked about this with, I think we had some Futurama characters when we did this. A static piece of data in your class means that every single object refers to the same one. Whereas an instance piece of data, every single object has the same name for it, but maybe a different value. So when I put static here, it changes it to this form, as opposed to with no static, it would be like this. So by putting instance, by saying private, static, my singleton being the type, and the name, there's now one of these instances for any sort of objects that I create. And the last piece will be something that's public. It will also be static. We'll talk about why in just a moment. And it's going to return, remember we put the return value next. It's going to return a my singleton. And I'm going to call this get instance. I'm going to set an initial value for this. You don't actually have to do this. This is automatic. But I'm going to set this to be empty. Null essentially means empty in this context. Sort of like setting an int to 0. It's empty right now. There's nothing there. It's effectively 0. So if I call get instance, it's public, so I can call it from outside this class. If I call get instance, I'm going to check if instance is null. Then I'm going to do something. Right after checking that if, I'm going to return instance. Right? Because this method returns a my singleton. Instance is a my singleton. So I can return instance from this method. It's get instance. It's basically just a getter. Just like we had get radius in our circle, for instance, our circle class. But if the instance is null, so if it's empty, then I'm going to create an instance of my singleton. There's the new my singleton. I can call new my singleton from inside the class, even though it's private. So if the instance is empty, this variable, which it will be at the beginning of your program, this variable is empty. If it's empty, then create a new one and return that one. This is it. This is all the code for a singleton. You can add whatever else you want in here. You could have a bunch of instance variables. You could have a bunch of methods. We could actually add this type of code directly to critter, and then critter would be a singleton. But this is the standard code you need in Java for a singleton. You need a private static mySingleton variable. You need a private constructor that does whatever you need it to do. And you need a public static function that returns a mySingleton. If instance is empty, create a new mySingleton and return that instance. Now, I understand if you don't know exactly sort of how this is going to work, or you don't sort of fully understand the method being sort of static and stuff. That's fine. Lots of patterns like this, it takes a bit to sort of go through it and sort of get through it to really understand what it's doing and how it works. There are much more complicated patterns out there that can take a significant amount of time to figure out about why it works. But I want to show you with a relatively small amount of code, we actually just satisfied all of the sort of issues that we want to fix. One instantiated object, and it should be available globally. We actually have that right now, just with those three sort of segments of the code: the variable, the constructor, the method. So how do we use it? I still can't do this. That's the power of this method being static. Remember how we use, let's see, if we did something like, delete this line here. If we said something like double A equals math.pow and a 5 and a 2, for instance. Math is a class. But I'd never have to do this. I don't have to say math equals new math to use power or square root or absolute value. I don't have to do a line like this. That's because pow is static. So I can just use the path, the class name dot the function, because pow is static in the math class. So the same process applies here. Get instance is static in the mySingleton class. So I can write a line that looks like this: mySingleton dot get instance. This works because get instance is static. What does this do? It returns a mySingleton instance, so I can say singleton ms equals this. The first time this gets called, which is right here, what happens? Instance is empty. So it creates a new mySingleton and returns that. If I call this again, if I do it a second time and give it a different name, so maybe ms2, so ms1 and ms2. I call it again. It comes back to here, and instance is not empty at that point. We already gave it some value. So it skips the if and just returns the instance. So what you'll see based on this, let's do a couple extra prints in here. You'll see this is going to be the first call. And then we'll have the second call. And I think in the mySingleton class, let's throw a new line in here after this one. So we have the first call to it, and we have the second call to it. And when I run, you see that after the first call, we get the created my singleton. The first call went in, instance was empty, we called new singleton, which created the object, so that's why we got the print. The second time we did a call, I don't print anything because I didn't run the constructor again. I skipped this if and just returned the instance. There's only ever one of these. Once this is full of an instance of my singleton, then we never create another one. It's impossible in the code that I've written to create more than one of these objects because I don't have access to the constructor. All I have access to is this. And it will never call this line more than one time. The first time you call get instance. Otherwise, it just returns the same one. And what you can also do to check this, remember that you can't compare the contents of objects with an equals equals. You always have to use like a dot equals method. That's why we have strings. We use string one dot equals string two. We have to use that for our strings. But if you use equals equals, it actually does test something interesting. It tests the memory location. Is this the identical object? So I can test that here. I can say if ms1 equals ms2, then let's print they are exactly the same. So if these two are exactly equal in memory, so in your RAM, if they point to the same location in RAM, then it's going to print this out. So if I run, there we go. So they are identical objects because they are this one that got filled in by our one call to my singleton. So some design patterns are easy to deal with. Some are much more difficult to implement. This one is useful for, in the game dev class, I use it for managers. If I have a sound manager or music manager or an overall game manager, making it a singleton can be quite useful. It can still lead to problems, but it is something useful that you can do to make your life easier in some situations. So even if you don't fully understand what this sort of singleton thing is doing, that's okay. Like I said, we talk about it more. I talk about it more in CS2 in the blackjack game that I work on as a project in there, along with you guys. There's some stuff that could be turned into singletons that I talk about. So you will see more of this type of stuff. But I just wanted to introduce you to a first taste, to know that there are these things out there that can help you achieve certain goals with your programming or whatever sort of program you're trying to write. If you're looking online somewhere trying to figure something out, maybe you're trying to write some specific type of code, you're looking online and you see somebody talk about a design pattern. They're not scary things. They're just ways to program to solve certain types of problems. So if you see a design pattern and you're interested about it, there's lots of them out there. Things like a very common one is a factory pattern. It takes a bunch of classes and it uses, I think minimum it's like 4 classes, and it has them connected in particular ways. But it's just a way to solve particular types of problems, and they're really, really useful. So if you're out there looking at stuff or you want to learn more about some of these design patterns that might be useful, I highly encourage you to take a look at them if you see like a reference to one in some code that you're using or something. And like I said, in future classes that you take, you will likely see more of these. I think in the blackjack game that I work on next semester, we talk about singleton some, and we talk about a factory pattern a little bit as well. So there are a couple that I talk about there, and then obviously in other classes I talk about other ones too. So yeah, that's basically it. I didn't want to take too much you guys' time. I know that break and stuff is coming up, and folks probably just want to be finished with classes soon today. So that's basically all I got. Make sure to turn your homework in tonight. Make sure it's pushed up to GitHub Classroom. That'll likely be the last one There's not really enough time for another one. There's 3 more lectures after this one. 2 of those will be taken up with our review, and the other one will be on another topic. So there's not a whole lot left. So this will likely just be your last assignment. I can stick around, of course, until 10:50ish. I have another meeting that I have to do after that. But I can stick around if there's some questions about the calendar stuff. But otherwise, that's all I got. So have a good Thanksgiving, and I will see you guys after break.
Excuse me, Professor.
Mm-hmm. Yep. What's up?
When I was signing up for classes, I got your ADM class for next semester. Is there a way that like sometimes